Hey folks, Ms. Gosling here. In this video, you're going to learn about hydroelectric power. By the end of the video, you'll be able to quantitatively analyze the energy provided by hydroelectric dams. So let's go ahead and get started. So hydroelectric power occurs when we harness the gravitational potential energy in water and use it to generate electrical power. So before I get too much into the how, I want to just quickly talk pros and cons. So first of all, hydroelectric power is renewable and does not exacerbate climate change. But it is location dependent. That is, you can't have much of a hydroelectric dam if you are not on a river. There are significant ecological impacts associated with damming rivers. So it can, for example, very negatively affect your animals the animals and plants that live in the river. It can also change the surrounding land, as species who eat things that live in the river, for example, lose their access to the things that they eat. And then finally, they can have potential economic impacts by negatively affecting, for example, fishing industries. So, as promised, let's go ahead and get a little bit into how hydroelectric power works. So, hydroelectric power is actually really cool because the concept behind it is very simple, and that is when water is up high, it has mass and it is off the ground, so it has some kind of gravitational potential energy, or U sub G. If as it goes down, as it moves downwards, of course, some of that energy, that potential energy turns into kinetic energy. We can use that to move a pump, thus generating electrical energy. So the math here is actually really simple, and that is that the power generated is going to be equal to the mass times the, or it's going to equal, let's more quickly say that it's going to be the amount of potential energy that is converted into electrical energy per unit time. So our power is m times g times the difference in height between our upper reservoir and lower reservoir. So my delta H here, divided by the time that it takes for that mass of water to go through my power plant. So to go through my chute here. Now, one thing you should know, though, of course, is that we usually don't measure water by mass. Instead, we'll look at the volume of water passing through. Now, I know that my density is equal to mass over volume. So therefore, the mass of water that passes through my power plant at any given time is equal to the volume passing through times the density of water. So often, I will write my hydroelectric power equation as volume times density times G times the height divided by time. And there we have the hydroelectric power generated by a dam. So let's go ahead and look at an example. Water from a pumped storage system falls through a vertical distance of 260 meters to a turbine at a rate of 600 kilograms per second. The density of water is 1,000 kilograms per meter cubed, and the overall efficiency of the system is 65%. Calculate the power output of the system. So looking at our givens, and actually before I do that, I'm going to go ahead and draw my picture. So my water starts up here, travels downward to my dam, and in that time, it's going to go through a height of 260 meters. And that's kind of the key here. Anywho, let's go ahead and look at my givens. So I know that delta H is equal to 260 meters. I know that my mass over time is equal to 600 kilograms per second. And I know that the efficiency of my system eta is 65%. So only 65% of the water traveling through the system is converted into electrical energy. And that is going to go ahead and lead me to my unknown, which is going to be the output power of my system. So my equation here, what I'm going to do is I'm going to go ahead and actually start with, I'm going to start from the end. So I'm going to start with eta is equal to my power out over my power in times 100. Now, in the past, we've used energy instead of power, but remember, energy per second, our power is just our energy over time. So the amount of energy being output in a given time is going to be equal. So the time here is going to cancel out, and it is so we can essentially key takeaway here, guys. We can use power and energy interchangeably when we're talking about efficiency. So with that, I know that my power output is going to be eta over 100 times my power in, or 0.65 times my input power. That brings me to my next equation, which is that the power in is equal to mg delta H over time. So my power out is equal to 0.65 times mg delta H over T. And now I'm ready to sub and solve. So my power output is going to be 0.65 times mass per unit time, which is 600 kilograms per second, times 9.8 times 260 meters. So my power output is going to be approximately 990 kilowatts, or 990 joules per second. And there you have it, guys. That is how I solve hydroelectric power problems. So let's talk takeaways. First of all, hydroelectric power is generated by converting gravitational potential energy into electrical energy. Hydroelectric power is renewable and does not generate greenhouse gases, but it can devastate ecosystems. And finally, the power produced by hydroelectric dams depends on the height of the dam and the volume of water running through the dam per second. So there you have it, guys. That's everything there is to know about hydroelectric power. Well, for now. So it is now your turn to try solving some problems. Best of luck and happy solving.